Hi everyone, and welcome. I'm Greg from the Model Build and Assembly team, and we're going to walk you through some key additions for Model Build and Assembly for 2025.1 HyperMesh. So our focus today is on some practical improvements to the Model Build and Assembly workflows that will reduce manual effort and mesh more naturally with some existing customer processes. We'll start with a new feature I'm excited about. So Model Update, it lets you import the latest geometry, compare it against your current model, and update only the parts that have changed. This will help cut down that typical update time for a model from hours to minutes and keeps this CAE data aligned with the latest and greatest CAD, which is really important. Making design decisions on the current design rather than something that's been left behind. Integrated composite support next, where we can store now Clyde-based data inside each part representation, so composite definitions that live in our libraries, and we get collaboration. Our revised XML export and include workflow now writes subsystem comments directly into the include files, so we can have the subsystem teams work independently without loading the full solver decks and integrate seamlessly with those already using include-based organization. New part sets tools smooth the transition from component and assembly-based modeling to part-centric workflows. And we're going to close with a look at the latest CAD reader updates. With this point, I'll hand it over to Yanni. So let's jump in.
To present Model Update tool and a solution designed to automate the process of updating CAD and CAE models. This tool ensures consistency across versions and significantly reduce manual intervention, making it particularly valuable in collaborative environments or projects involving complex assemblies. Let's start with the first slide. Using this tool eliminates the need to track changes and rebuild your whole model from the scratch. It updates the CAD automatically. This tool tracks all the changes across the revisions and highlights parts for quick identification. Only the impacted parts for quick identification. It also updates only the parts that already changed, so it does not update the whole model, only the parts that change, preserving the mesh and the whole assembly structure. As a result, it cuts significantly the time to minutes, from hours to minutes, even in high complex assemblies, high complex models. This tool is easily accessible from the ribbon menu under the Assembly tab, making it easy to find it. Using this tool, a user can use predefined filter list or use an external file to filter some parts, offering flexibility for managing different update strategies. Moreover, users have the option to automatically delete the parts that has been removed, and this assures that the model remains clean, organized, and up to date. Also, this tool provides a built-in support for revision comparison, where users can compare revisions using various comparison rules, such as major revision or library revision, and also generates a detailed report at a specified location provided by the user. And this comes to an ease of the operation. This provides ease of the operation and valuable insights into the model changes and also enhanced traceability. The model update process functions. The first one is the revision check. It identifies the parts that share the same unique identifier UID, and it checks for change revision. All parts that has changed revision are categorized in a new group called revised parts. All the parts that have the same revision, it will be organized in a group called carryover, and it will be excluded from the checks. The most important thing here is the UID, that in all parts needs to have the same unique UID to run this operation smoothly. Now, for all the revised parts, we perform the following checks, like topology check that detects structural or geometry modifications in the parts, and also we detect metadata and PDM attributes differences in these values. And we also categorize them in separate groups. We have many categories, so the user can easily detect the changes. For topology changes, we do classify in 10% increments, so the user can easily see the parts that change and in which percentage. Also, we list parts with modified metadata or PDM attributes values that has changed in separate groups, part sets, so the user can also detect them. And last, we highlight all the added, removed, or filtered parts that provided by the user through the filter list or the external file, so that he can track all the changes in his model. Now, from the reporting side, we do two different things. First one is the visual grouping. We are creating part sets that automatically generated to highlight the differences and all the updates. And we also provide dynamic HTML reports to summarize changes in topology, metadata, and PDM attributes for easy review through these reports. A critical benefit of the model update tool is maintaining a consistent model state. As updated parts are integrated into session, the model remains accurate, aligned with the latest data, and ready for further development or analysis. Saying this, I will show a demo how this tool works. Here, the user selects his model for the session. He applies his filters through clicking on the filter manager or even providing a file, an external file. He clicks on update, and after a few seconds or some minutes, we will see the updates in the session. It creates part sets where a user can easily detect the changes in his session, and also provides dynamic reports to detect them. As you can see, many part sets are created based on the rules and the checks we did previously, so we can easily detect any change in the session. After the model update finishes, it provides also a report, so the user can easily track the changes and see some graphs and some summary based on the results from the checks we made. We can see that we have a summary. We have some graphs that analytically explain the model, pictures of the models, both from the session and the incoming one, and all the categories as described previously, revised parts, PDM metadata, some filter parts, and all the parts that have been either added or removed from our session. Last, we have carryover parts. User also can check on the side and go through categories to navigate through these dynamic reports. This is all from my side. Thank you all, and ask Stratos to continue with his presentation.
Hello all, my name is Stratos, and I will talk to you about the composite entity support in part representations. And to begin with, integrating composites and especially ply-based modeling in parts allows aerospace and automotive industries to introduce the general model build strategy in their composite use cases, taking advantage of its benefits. What has introduced in 25.1 is the ability to save, load, and unload the composite entities in part representations. More specifically, laminates and their contents, meaning their plies and sequences, which are lists of plies, refer to the corresponding parts via shapes, which are sets of elements. Properties and materials related to the composite entities are stored in parts 2, along with the tables, systems, and their collectors, which all are needed for the definition of fibers orientation. To allow the representations operation, a major rule had to be established, and says that each laminate, either it is a ply laminate used on flat and curved structures, or it is an interface laminate which contains sublaminates and is used for more complex laminated structures, must belong wholly to one part. That means that the sets which refer to plies of a laminate should contain elements that belong to components of exclusively one part. If not, the shared laminate is not saved in a parts representation.
Hello everyone. I will begin my presentation with the changes made to the HyperMesh XML comments in the solver text. A common comment from users is how much impact the number of HyperMesh XML lines have in their solver text. Starting from version 25.1, users can choose how this block will be exported. There are 3 available options: a binary, multiple lines, single line, which is the default one, and they are applicable to paths, subsystems, connectors, ID rules, and material metadata. Let me walk you through with a live demo. So if you open HyperMesh, you can change this from the preferences. So you have to go to the File, Preferences, and go to HyperMesh, Application, and here you can see the XML export method with a drop-down menu with all 3 options. I have already created a small sample deck. Here, as you can see, this is the original format, which we had so many years. And as you can see, it takes several lines for the information. What we have developed is this format, which is a single line. All the information is here, it's the same, but as you can see, it takes a few lines in your solver deck. The third and final option is the binary one, which is the same as the previous, but in a binary format. So if I continue with the subsystem include comments, the main challenge that many users faced with the subsystem workflow was that they had to load the entire model to utilize the subsystem workflow. Until version 25, all the subsystem information was written in the header deck and not in the corresponding include file. From version 25.1, the subsystem information will be written directly to the include. This will allow the users to load only the include they want to edit. The benefits of these changes are, firstly, that each include file read has the correct representation and revision assigned. Secondly, that the subsystem workflow can be utilized without requiring the whole deck. And thirdly, it saves time and computing resources. In this slide, as you can see, we have on the left side an example of the format. As you can see, the XML comments are all printed in the header deck and not in includes. And on the right side of the slide, you can see that all the information of the include are printed there and not in the header deck. The next feature is the create part sets workflow. Another new feature that we have made for version 25.1 is the create part set tool. This tool is very useful for the transition to the part workflow. Currently, the assemblies are used for capturing the CAD hierarchy and for user groupings. This tool takes the assembly and turns them into part sets. Common scenario is that assemblies have the same component repeatedly used in multiple assemblies. Part assemblies do not support this use case, and part sets do. Hence, that is why assemblies will be mapped to part sets. The users can execute this tool either from the model browser by right-clicking on the assemblies folder, or from the assembly browser, again by right-clicking. Additionally, from the assembly browser, we provide the option to map the assemblies to part assemblies. This is suggested for capturing the CAD hierarchy and create part sets for every other case. For solver decks, we also provide the option to run this tool during import. If you see here, I have a simple example. We have a model with 4 assemblies with some components inside, and the second one has also a nested assembly. After you run the create part sets tool, you will see that these assemblies are mapped to part sets. And if I continue with the changes on libraries, in version 25.1, we have made improvements to the library manager workflow to make it more user-friendly and flexible and faster to use. Firstly, we have separated the process of creating a library and adding one. This gives to the user more control and clarity when managing libraries. Additionally, we added the option to connect or disconnect to a library by simply clicking the icon in the first column.
I will go towards our CAD readers now. In 2025.1, we have done a lot of changes to our CAD readers. We have introduced new ones. So I'll start going about them. Okay. So in 2025.1, we have introduced a ECAD reader. It's our first implementation of ECAD systems into HyperMesh. It's a CN-based architecture. CN architecture is something that we introduced 3 releases back. It's our robust framework. CN stands for CAD neutral, meaning that it is a module in itself that can be utilized by different applications. It's very useful. That way we can commonize the CAD modules across our different products. The backend is already optimized because it uses the Polex reader internally to read the ECAD information and parse it correctly, and it also gives us all the enhancements that Polex already do. They are the ECAD folks who know the format inside out, and it's best for us to quickly react to market changes and CAD reader changes. So that way we have optimized the backend. And it's already extensively evaluated by AE teams across the globe, and they really like the way it is implemented. So we have done a bit of homework this time when introducing a new reader, and I think it's ready for the prime time. In the next slide, I'll quickly show you the demo. It's really straightforward. No new learning is needed. You'd go to File, Import Geometry, and you select the ECAD model that you have. Different file formats are supported. We have, of course, documented those. The same options are available for assembly, topology, entities. And in entities, if you look, we are even giving an option to import the zero thickness layers. Once the CAD comes in, we actually typically also bring in all the metadata that is associated with particular part, and we try to distinguish parts between electric layers and parts, because that's what is needed for ECAD world. So that's a bit about ECAD reader. Moving on to other CAD readers, there have been notable enhancements to most of the CAD readers. HM 2025.1 is a special in the sense that it contains our third-party libraries. There are 2 versions of them. One is the previous library support, which is at the end of the life, and also the newer one that was provided to us. The newer one happens to be the default, but you will see that with the new reader, there are infrastructure changes, and we although we tested all the use cases that we have, there might be use cases that we didn't have with respect to CAD. And some of those we are a bit skeptical might not be supported. So this is the reason we have packaged both the libraries. Unfortunately, we cannot internally decide which one to use. So the decision has to be coming from the user. And in order to use the previous reader, all user can do is, let's say they are importing a step file, they can go to user defined and turn on this option, use legacy CT reader equal to on, and they will be able to use the previous set of libraries which were mature, and import the CAD files. This is already documented in release notes. So if you miss this particular part of the slides, you can always look at release notes for 2025.1. So what is the latest library giving us? Because we are packaging both, right? So they are bringing in the support for NX 2412, Creo 11, Inventor 2025, CATIA V5 R34, SolidWorks 2024, and the biggest enhancements came for 3D XML. The 2024 3D experience is out, and there are format changes, and those files were not supported into the previous reader. Those are supported now. With the previous reader, you still can read NX2406, Creo 11, Inventor, and all the neutral file formats such as STEP, IGS, and so on and so forth. For NX, there is another update. NX2412 is out, and we are also supporting it through native reader. Many customers still prefer native reader to third-party reader, so we are up to date there too. Coming to JTs, it's actually the long form stands Jupyter Tessellation. We have updated our JT Open Libraries to 11.6. This is the latest and greatest right now, and we are up to date with that in 25.1. JT export now includes support for version 10.10. So if you go to File, Export, Geometry, and if you select JT, on the subsequent screen, you will be able to select the version 10.10, which kind of is their latest in terms of versioning also. And also in 2025.1, we have started supporting XTBREF geometry as a part of JT file exports. Having said that, that's pretty much all the updates I had to share about the CAD readers. Thank you, everyone.